In the dying days of World War II, with cities in ruins and empires on their knees, a sound pierced the sky that no one had heard before. A deep, unnatural roar, like thunder drawn through metal. Allied pilots looked up, and for the first time, they weren't looking at propellers. They were looking at something else, something faster, sleeker, and deadlier. It was the world's first operational jet fighter, the Messerschmitt Me 262, and on that day, the age of the jet had begun. Imagine this. You're flying a high-altitude bombing run in 1944, cruising at top speed in a B-17. You think you're safe, until out of nowhere, a blur slices past you at 540 miles per hour. Before your gunner can blink, your wingman is down in flames. This was no ordinary dogfight. This was the moment. Aviation history split in two. But how did Nazi Germany, battered, blockaded, and stretched thin, manage to produce a plane so advanced that it could outrun anything in the sky? And why did the Allies, with all their might, fail to match it before the war's end? This is the story of how jet propulsion went from theory to terror, from drawing boards to dogfights, and how one machine forced the entire world to rethink the future of warfare and technology. Today, jet fighters dominate modern skies, symbols of national pride and technological might. But it all started here, with a prototype pushed into battle before its time by a regime desperate to win, and engineers who were far ahead of theirs. In this video, we'll uncover the untold saga of the Me 262, from early concepts of jet propulsion to its dramatic debut in the skies over Europe, its impact on military aviation, and how it sparked a revolution that still shapes the skies today. Welcome to a story where speed rewrote the rules, and the world would never be the same. Before the jet age began, mankind had always looked to the skies with one central limitation: propellers. Since the Wright brothers first left the ground in 1903, the evolution of flight depended almost entirely on spinning blades and piston engines. These machines revolutionized transport, war, and exploration. But by the 1930s, even the best propeller-driven aircraft were starting to hit a wall, literally. As speeds increased, so did air resistance. Propellers became less efficient at higher altitudes and velocities. Engineers began noticing that no matter how powerful they made the engines, they couldn't push their planes much faster without the design becoming unstable or the fuel demands becoming absurd. The aviation ceiling, once so limitless, now had a hard cap. The sky, it seemed, wasn't infinite after all, but a few visionary minds dared to think differently. They imagined engines that didn't rely on spinning propellers at all, but instead pushed air backwards with explosive speed. Jet propulsion, as the theory was called, wasn't entirely new. In fact, the basic concept dated back thousands of years. Ancient Greek inventor Hero of Alexandria had sketched a device called the aeolipile, a steam-powered turbine that spun when heated. It was a toy, a curiosity, but the idea of thrust from reactive force had been born. Fast forward to the early 20th century, and engineers began applying similar concepts to aviation. In Britain, a young Royal Air Force officer named Frank Whittle proposed a turbojet engine in 1929. His designs were innovative, compact, and startlingly ahead of their time, but he was met with skepticism, bureaucracy, and budget cuts. Britain's Air Ministry didn't believe the technology was realistic, not yet. Meanwhile, across the Channel, a German physicist named Hans von Ohain was working in parallel, entirely unaware of Whittle. In the mid-1930s, he began designing his own jet propulsion system, eventually collaborating with aircraft manufacturer Ernst Heinkel. Where Whittle was ignored, von Ohain found support. By 1939, the Heinkel He-178, the world's first aircraft to fly under turbojet power, lifted off the ground. It wasn't fast, and it wasn't armed, but it proved the concept. Jet propulsion worked. At this point, the geopolitical situation in Europe was spiraling toward war. Hitler's rise, Germany's military buildup, and the brewing global conflict accelerated interest in any technology that could give an edge. And suddenly, what had once been theoretical became urgently practical. The question was no longer, can we build a jet engine? It became, how fast can we turn it into a weapon? That urgency birthed a technological arms race, quiet, secret, and far ahead of public awareness. Behind locked hangar doors and deep in engineering labs, jet propulsion was maturing into something no longer theoretical, something dangerous. Yet it's important to understand, the Me-262 didn't appear out of nowhere. It stood on the shoulders of a century of dreams and decades of quiet experimentation. It was built on the failures and forgotten notes of men who worked in obscurity and often in frustration. But now, the world was listening. The stage was set. The concept was proven. All that remained was the leap, the first combat-ready jet fighter, and Germany was about to take it. By the early 1940s, Germany was no longer content with theory. The Luftwaffe, once the pride of Hitler's fast-moving blitzkrieg strategy, was struggling to maintain its edge. Allied aircraft production had surged. British Spitfires and American Mustangs dominated dogfights. German fighters, fast but still bound to propellers, were becoming outmatched. Behind the front lines, however, something extraordinary was being assembled. At the Messerschmitt Company, led by engineer Willy Messerschmitt, a new project was underway, Project 1065. It was nothing less than a fighter aircraft unlike anything the world had ever seen. Sleek, twin-engine, jet-powered, and designed to hit speeds propeller planes could never dream of. The goal was simple and yet audacious: to build a jet that could take off from conventional runways, outrun Allied aircraft, and rain destruction before vanishing into the sky. But the road to the Me-262 was anything but smooth. The first prototype, codenamed Versuchsflugzeug 1, V1, was completed in 1941. It looked like something from the future: swept-back wings, tricycle landing gear, and twin jet engine pods mounted. Under the wings, it was beautiful, dangerous, and unfinished. Why? Because there was no engine yet. The Junkers Jumo 004 engine, the heart of the Me-262, was still in development. So the first flight of the V1 was made with a temporary piston engine mounted in the nose. Yes, the world's first jet fighter took its maiden flight with a propeller strapped to its front like a crutch. It was an embarrassing compromise, but also a testament to German determination. They had to test the airframe, even without the engine it was meant to fly with. When the first working Jumo 004 engines finally arrived, another problem emerged. These early jet engines were temperamental, fragile, and prone to failure. The materials needed to build high-temperature turbine blades, like heat-resistant alloys, were scarce in war-ravaged Germany. Engines often lasted only a few dozen flight hours before needing replacement, but they worked. In July 1942, the first true jet-powered flight of the Me-262 finally took place. No more propeller, just raw, searing thrust from two jet engines. The plane ripped across the sky at speeds over 850 kilometers per hour, a figure that left Allied intelligence stunned when they first learned of it. The Me-262 was fast, far faster than any Allied fighter in the sky, and yet, despite this breakthrough, politics nearly killed the program. Adolf Hitler, increasingly isolated and erratic, insisted the Me-262 should be a fighter bomber, not an interceptor. He imagined it carrying bombs to strike ground targets, rather than focusing on air superiority. This decision delayed mass production and re-engineered the aircraft into a dual-role weapon, one it was never truly designed. To-be Messerschmitt engineers were furious. Pilots begged for the plane to be used purely as a fighter, but Hitler, obsessed with vengeance weapons, wanted something that could bomb London and fight fighters. So the Me-262's potential was stifled, but not extinguished. Meanwhile, test. Pilots began reporting astonishing performance. Veteran Luftwaffe ace Adolf Galland, one of Germany's top pilots, was among the first to fly the Me-262 in its combat-ready form. His verdict: it felt like angels were pushing. The acceleration was blistering, the roll rate was smooth, and its 430mm cannons, mounted in the nose, made it a flying tank. It was the first aircraft in history that could choose when to fight and when to vanish. It could zoom in, fire, and retreat before the enemy even had time to react. But the Me-262 faced one final obstacle: time. By the time the aircraft was approved for full deployment in 1944, the war had turned. Allied bombers were pounding German cities daily. Fuel was scarce. Factories were under constant threat. The Luftwaffe was bleeding pilots faster than they could train replacements. Still, the Me-262 made its debut, and the results were terrifying. In its first engagements, it tore through Allied bomber formations with ruthless efficiency. Bombers couldn't outrun it, escorts couldn't catch it. It was a ghost, seen only for a moment, and then gone. But no matter how advanced the machine, it couldn't change the course of a collapsing war. There were never enough Me-262s and never enough skilled pilots left to fly them, yet even in those final months, the Me-262 had done something extraordinary. It had proven that jet propulsion was no longer an experiment, it was the future of flight, and the rest of the world was watching. The Me-262 was more than a weapon. It was a message from the future, a whisper of a new era cutting through the smoke of a dying war. Though it came too late to change Germany's fate, it didn't disappear into history. Instead, it seeded a revolution, one that would unfold over decades, transforming the way humanity ruled the skies. By mid-1944, the Me-262 was finally combat-ready. Deployed under the command of Jagdverband 44, an elite fighter wing led by General Adolf Galland himself, the aircraft began its first true dogfights, and it didn't disappoint. In its first month, a handful of Me-262s managed to down dozens of Allied bombers with minimal losses. Its sheer speed, nearly 200 miles per hour faster than the fastest Allied escort, made it virtually untouchable in straight flight. Pilots described the experience of flying the Me-262 as gliding on lightning, but the plane had weaknesses. Its engines, still fragile, required careful throttle management. On takeoff and landing, it was vulnerable to propeller-driven fighters. Like the P-51 Mustang, Allied pilots quickly learned to stalk airfields and hit Me-262s during these critical moments. Despite this, the jet's presence shifted Allied strategy, forcing changes in bomber formations, fighter patrol routes, and even the pace of bombing campaigns. When Germany fell, the world raced to steal its secrets. The Allies, particularly the United States and the Soviet Union, scrambled to capture Me-262s, along with the engineers, blueprints, and research labs that birthed them. The US launched Operation Lusty, a mission to recover German aviation technology. Dozens of Me-262s were shipped to America, where they were reverse-engineered and flight-tested. At the same time, engineers like Werner von Braun and aircraft designers from Messerschmitt were quietly relocated under Operation Paperclip, forming the backbone of post-war American aerospace innovation. The Soviet Union followed suit, capturing Me-262 variants and drawing heavily on their design to influence early MiG fighters. The Me-262 was not just a German invention anymore. It had become the template for global jet aviation. Within just 2 years of the war's end, the jet age officially began. In the United States, the Bell P-59 Aerocomet, America's first jet fighter, had already been flying in secret during the war, but it was slow, clunky, and underwhelming. It was quickly replaced by something far more effective, the Lockheed P-80 Shooting Star, designed by the legendary Clarence Kelly Johnson in just 143 days. The P-80 was sleek, efficient, and combat-ready. Britain, meanwhile, introduced the Gloucester Meteor, which had been used late in WWII to intercept V-1 flying bombs. It was the only Allied jet to see combat during the war. But now it took center stage as Britain's primary jet platform, eventually forming the basis for the RAF's peacetime fleet. The Soviets, working from captured Mi-262 blueprints and their own innovations, developed the Mikoyan-Gurevich MiG-9, quickly followed by the iconic MiG-15, a plane that would come to define the early Cold War skies. Jet propulsion was no longer experimental. It was now the global standard. The first true test of jet fighters in battle came over the skies of Korea. The Korean War became the first conflict where jet aircraft fought each other directly. On one side, the United States fielded the F-86 Sabre, a swept-wing, high-speed jet fighter designed for agility and gunfire precision. On the other, Soviet-built MiG-15s, flown by Chinese and North Korean pilots, and covertly, Soviet pilots as well. The battles that took place in MiG Alley became legendary. The Mi-262's legacy lived on in both fighters. The swept-wing designs, jet engine configurations, and dogfighting tactics all trace back to those final days of WWII. The F-86 and MiG-15 were technological cousins, and the war proved one thing: jet fighters had forever replaced propeller aircraft in air-to-air combat. With the foundation set, aviation entered a period of breakneck innovation. In 1947, Chuck Yeager broke the sound barrier in the Bell X-1, shattering yet another perceived ceiling. From that moment forward, every major nation pushed its jet programs to go faster, climb higher, and strike harder. America unveiled the F-100 Super Sabre, F-104 Starfighter, and later the F-4 Phantom, each representing major leaps in speed, radar, and missile systems. The Soviets countered with increasingly advanced MiG models, MiG-17, MiG-19, and MiG-21, culminating in highly maneuverable jets that would see action from Vietnam to the Middle East. The British introduced the English Electric Lightning, capable of Mach 2 speeds, while the French delivered the Dassault Mirage, another iconic design inspired by swept-wing aerodynamics that had first proven effective in the Mi-262. Every feature, from engine placement to swept wings to nose-mounted air intakes, could trace its lineage to that original German breakthrough. By the 1970s, speed was no longer the only goal. Jet fighters began evolving into multi-role platforms capable of performing bombing runs, interception, air superiority, and reconnaissance, all in one airframe. The US introduced the F-14 Tomcat, F-15 Eagle, and later the F-16 Fighting Falcon, combining power, avionics, and precision. These aircraft didn't just fight, they thought. Onboard computers, radar lock systems, and infrared targeting transformed the way pilots interacted. With the battlefield, the Soviets weren't far behind. The MiG-29 and Su-27 series challenged Western dominance, boasting high maneuverability and cutting-edge engines. Once again, the ghost of the Mi-262 lingered. These machines had evolved far beyond their ancestor, but they still carried its DNA. The 21st century ushered in a new kind of jet, one focused not only on speed and firepower, but invisibility and information dominance. The F-22 Raptor. And F-35 Lightning II represent the fifth generation of jet fighters, stealthy, networked, sensor-rich, and capable of flying missions undetected. They are built as much for data warfare as for dogfights. Russia's Su-57 and China's Chengdu J-20 continue the competition. Now, global powers aren't just racing for air dominance, they're racing for autonomy, hypersonic flight, and drone integration. Jet fighters are no longer just tools of war. They are symbols of national pride, of technological supremacy, of future potential. Yet all of it began with a fragile aircraft in 1944, rushed into battle by a crumbling regime. The Mi-262 was not perfect, but it was first. It introduced an entirely new shape to combat. It changed what was possible in the skies. And in doing so, it forced the world to leap forward, faster than anyone had anticipated. This is the legacy of the Mi-262, not as a relic, but as the beginning of a lineage, a line of evolution that still continues today. From the battlefield, over Berlin, to the stealth missions over the Middle East, to the AI-controlled drones of tomorrow, every fighter jet still whispers its name. The jet engine was no longer a novelty, it was a necessity. And the fighter jet, once an experimental weapon, had become a global standard. After the Mi-262's debut changed the face of combat, it didn't take long for jet fighters to leave the secretive world of military labs and become centerpieces of national defense strategies across the globe. By the 1950s, military aviation had entered a new era. One where being a world power didn't just mean having tanks and ships. It meant having jets, fast, modern, powerful jet fighters capable of defending airspace, delivering payloads, and projecting influence across borders. For the first time in history, nations no longer measured strength solely in manpower or naval dominance. Air superiority became the new high ground. The fighter jet became both a deterrent and a declaration. Countries raced not only to build better aircraft, but to showcase them in military parades, dogfight demonstrations, and high-stakes air shows. The Cold War amplified this transformation. As the United States and the Soviet Union escalated their arms race, fighter jets became symbolic trophies in a much broader contest. But while political tensions drove development, the cultural shift was just as profound. Jet fighters captured the imagination of an entire generation. Children who had grown up hearing stories of the Mi-262 or watching grainy footage of the Korean War now dreamed of becoming pilots. Fighter races became household names. Movies, magazines, and television shows glorified the cockpit, not as a battlefield, but as a stage for courage, speed, and human skill. In the civilian world, the influence of jet propulsion expanded rapidly. Though fighter jets remained military tools, the same engines powered the rise of commercial jetliners like the Boeing 707 and the de Havilland Comet. The skies became busier, the world became smaller, and the public began to view air travel, and by extension, flight itself, as something exciting, accessible, even routine. Meanwhile, jet fighters kept evolving. Each new generation came faster, stealthier, smarter, and with each leap forward, the military-industrial complex grew, drawing more investment, more attention, and more dependency. By the 1980s, a single aircraft like the F-15 Eagle or MiG-29 wasn't just a machine. It was a billion-dollar platform, supporting thousands of jobs and standing as a pillar of a nation's strategic doctrine. And countries that once relied on imported aircraft now sought to build their own. Nations like India, Israel, South Korea, and China began developing indigenous fighter programs, further democratizing the jet age. Today, even small nations possess air forces equipped with jets derived from the legacy of the Mi-262. Jet fighters are now part of a global language of defense, diplomacy, and deterrence. But more than that, they've become a permanent fixture of the modern world. They patrol the skies during peace, they respond first in conflict, and they remind everyone, whether flying overhead in silence or breaking the sound barrier in thunder, that the sky is still a contested space, shaped by an invention that redefined everything. The revolution didn't come in a single battle or in one decisive campaign. It came the moment the jet engine proved it could change the sky and never gave it back. Today's jet fighters are no longer defined by brute speed alone. They are digital fortresses, flying computers brimming with sensors, stealth coatings, and AI-assisted systems. From radar-evading silhouettes to high-bandwidth satellite links, the modern jet fighter has become the most complex war machine in human history, and its evolution has never slowed. The last 20 years have marked the dawn of what aviation experts now call the fifth generation. These are fighters built not just for superiority in the skies, but for survivability in the age of electronic warfare, cyber threats, and real-time global conflict. The American F-22 Raptor, introduced in the early 2000s, was the world's first true fifth-generation jet. It brought together stealth, supercruise, agility, and unmatched situational awareness, capable of dominating in any theater, often before the enemy even knows it's there. Following closely was the F-35 Lightning II, a global joint development project that now operates in over a dozen countries. With variants adapted for vertical takeoff, carrier operations, and conventional airfields, the F-35 represents the broadest deployment of fifth-generation technology yet. Its networked architecture allows it to act not just as a fighter, but as a command node, relaying information to other aircraft, ships, and ground forces. Meanwhile, Russia's Su-57 and China's Chengdu J-20 have entered the arena, reflecting a growing multipolar world in military aviation. Both aircraft aim to combine stealth with long-range missile capabilities and agile dogfighting performance. While neither has reached the scale or interoperability of Western platforms, they signal a powerful truth. Jet fighter innovation is no longer the domain of a few. Diversification has also taken root. Nations like India, South Korea, Turkey, and even smaller players, such as the UAE, have launched indigenous jet fighter programs. The push for self-reliance in defense has become a strategic imperative in a world where alliances are shifting and regional threats are evolving. Beyond combat, the technology behind jet fighters is now influencing other sectors. Advances in engine efficiency, material science, and autonomous control systems have spilled into civilian aerospace and even commercial drone development. Supersonic civilian jets, once abandoned, are again being designed, this time drawing lessons from stealth fighters to reduce sonic booms and improve fuel efficiency. Yet this era is not without its concerns. As automation and AI enter the cockpit, militaries now face ethical debates. Should unmanned jets be allowed to make kill decisions? How do we prevent AI targeting systems from escalating conflict? And how do we balance national security with global stability in an age where a single fighter jet could spark international crisis? There are also growing environmental considerations. Jet fighters are among the most fuel-intensive machines in operation. As nations face climate commitments and energy transitions, the question of how to balance readiness with responsibility grows louder. Despite these tensions, the dominance of jet fighters in the 21st century remains unchallenged. Their roles have expanded from traditional air-to-air combat to surveillance, cyber defense, electronic jamming, and precision strike missions. What began as a desperate wartime experiment in Nazi Germany is now the backbone of global air power. Refined, adapted, and endlessly evolving, from the Me-262 to the F-35, the skies have become a web of strategy, speed, and silent strength. And the race continues. When we look back at the history of aviation, certain moments rise above the rest. Moments when the impossible becomes real and the course of human progress shifts. The debut of the Me-262 was one of those moments. It didn't just mark the arrival of a new aircraft. It marked the arrival of a new reality, one where the sky itself had to be reimagined. Before the Me-262, air combat was loud, close, and dependent on the whir of propellers. Fighters maneuvered in tight spirals, pilots relied on sight and reflex, and the pace of battle was fast but comprehensible. After the Me-262, everything changed. Speed became dominance. What couldn't be seen couldn't be stopped. The future had arrived, late, flawed, and fragile, but real. Its legacy isn't measured in victories. The Me-262 couldn't stop the Allies, and it didn't save the crumbling Nazi war machine. But it rewrote the blueprint for how wars would be fought from the skies. Every modern jet fighter, from the F-16 to the Su-57, traces its lineage back to this machine. Its swept wings, twin-engine layout, and concept of turbojet propulsion became standard architecture, not just in military design, but in commercial aviation as well. The very idea that you could cross oceans at jet speed, once unthinkable, was born in the same workshops that built the Me-262. More than that, it changed how nations thought about power. Air superiority became non-negotiable for any serious military. The balance of power shifted upwards into the clouds and never came back down. Technologically, the Me-262 opened floodgates. Materials science, engine theory, radar countermeasures, all were pushed forward by the demands of this new generation of flight. Even space exploration, which would follow just a decade later, owes part of its momentum to the breakthroughs forged in jet development. And yet, its most enduring impact may be philosophical. The Me-262 is a reminder that innovation doesn't always come from ideal places. It came from the heart of a regime bent on domination, yet it became a stepping stone for global progress. It taught the world that whoever controls the skies controls the story. Today, we live in the world it helped create. The jet fighter began as a radical experiment. But where is it going now? In the coming decades, we may look back at today's stealthy AI-assisted aircraft and see them not as the peak of aviation power, but as another turning point, a transition toward autonomous air dominance. Already, militaries around the world are testing drone wingman systems, pilotless jets that fly alongside human-operated fighters, sharing data, reacting in real time, and executing missions without putting a life at risk. Projects like the US Air Force's Loyal Wingman or the UK's Project Mosquito hint at a future where squadrons include both humans and intelligent machines, or perhaps eventually, only machines. These systems aren't just about replacing pilots. They represent a new philosophy of war, faster, quieter, algorithmically controlled. Meanwhile, hypersonic flight, the ability to travel at speeds beyond Mach 5, is no longer science fiction. Research into scramjet engines and heat-resistant materials suggests that jet fighters of the next generation might not just dominate the skies. They might blur the line between atmosphere and space. Imagine an aircraft that can strike a target halfway around the world in minutes and disappear into the stratosphere before radar can respond. Energy weapons, directed EMPs, real-time satellite integration, these aren't dreams. They're already in prototype, but with great capability comes great risk. Who controls these machines? How do we program ethics into algorithms? What happens when machines misread intentions, or when multiple nations trust their defense to lines of code? The jet fighter has always been a symbol of speed, of power, of supremacy. But in the future, it may become something else entirely. A thinking machine, a deterrent powered by data, a ghost that never sleeps. So we ask, will the skies of tomorrow be safer or just faster? And when the next leap comes, when the rules of flight are rewritten again, who will take the first step and who will be left behind? From the smoke-streaked skies over war-torn Europe to the quiet hum of stealth jets slicing through today's atmosphere, the story of jet fighters began with a bold, dangerous leap, the Me-262. It was imperfect, rushed, and born from desperation. But it redefined flight. It changed how wars were fought, how nations measured strength, and how fast the world could move forward. Every engine that roars today carries the echo of that first thunder. Every pilot who takes off rides on the legacy of those who once dared to outrun the wind. Thank you for joining us on this journey through time, technology, and sky-shaping innovation. If you enjoyed this deep dive into aviation history, don't forget to like the video, share it with your fellow history buffs, subscribe to the channel, and leave a comment below. Which jet fighter, in your opinion, changed the world the most? We'll see you in the next chapter of innovation.